Namaste. Welcome to the video lecture series on the chapter Periodic Table of an Element. In this video, that is video number 13, we are going to study some general properties of zero group element or 18 group element, which are also known as noble gases or inert gases, which are also called as noble gases or inert gases. So I have helium, neon, argon, krypton, xenon, radon, and organoson, which is a newly discovered element. Okay, now these are elements which we considered as a zero group element or 18 group element. Now, these elements we generally call them as a zero group. We generally call them as a zero group element because this compound, whatever these elements are there, they generally do not form any sort of compound with any other element. That means they do not form any kind of valency. So as their valency is zero, they are called as zero group element. As they have valency zero, they are called as zero group element. Now we have alkali elements. We call them as a monovalent element because they got one electron and they lose that electron and forms monovalent compound. That's why they are called as monovalent. But as this element do not show any tendency to form any sort of compound with any other element, that's why they have zero valency and hence they are called as zero group element. Now apart from that, you observe carefully, we have, in case of helium, it has got 2 electrons in its valence shell, so that we consider as an duplet condition. But rest all other elements, if you carefully look at, they have 8 electrons in their outermost shell. They have 8 electrons in their outermost shell. So which is considered as an octet condition, So helium has got duplet condition and other gases have got octet completed in their valence shell. Now to have a duplet or to have an octet in a valence shell is considered as a stable electronic arrangement, Because of this stable electronic arrangement, they do not show any ability to react with any other element. They do not show any ability or eagerness to react with any other element. That's why they are called as noble gases. Or inert gases because of their chemical inertness. See, this element, in case of helium, you have duplet completed. Rest all other elements, if you carefully look at, they have 8 electrons in its valence shell, which is considered as a condition of stability. So, due to this stable electronic arrangement, they are considered as a noble gas or inert gas. Now, unlike other gases, we observe that most of them are diatomic molecule, but these are generally considered as monoatomic. Other gases are reactive because they don't have octet completed, but as these elements have got their octet completed, so they are found in free state. Then these elements are generally colorless. And do not have any order. So these elements are generally colorless, orderless. That means they do not have any color, they do not have any smell, and non-flammable. That means they do not catch fire. And they show little reactivity. Now we have this reactivity has been observed for some of the compounds in terms of xenon. Xenon at a very higher temperature do combine with oxygen and fluorine in order to give you xenon oxyfluoride or xenon fluoride as a compound, and some compounds of kryptons have been identified and studied. So, but that's not at normal room temperature. At normal room temperature, this element show chemical inertness. They do not react. Now, only some specific element like xenon and krypton, they do combine with fluorine or oxygen in order to give compounds. So that's why I've used here word little reactivity. Now, these gases, all of them are gases. They have low melting point and low boiling point. Now why this is so? They have low melting point and boiling point because as these gases do not have greater tendency, that means interatomic forces of attraction is there. It's very like weak. So because of this weak interatomic forces are there, so those attractive forces are very weak. As a result of this, the melting and boiling points are very lower because these molecules do not tend to attract each other very firmly because of this weak interatomic forces. As we move down the group, that means from top to bottom, the atomic size increases. So with that, the boiling point and melting point also increases, and density also shows a trend increases. So here, as we move from top to bottom, with increase in atomic size, the melting point, boiling point, and density generally shows an increase. Now, these gases, despite of their inertness, we do find the uses of these gases. We do find uses of these gases in various fields, like from an incandescent bulb to the lasers. Okay, so we nowadays we don't use those bulbs actually. We are using LEDs and other lights, but the bulbs has got filament in them, tungsten filament. Now we have helium. When we use helium, now helium is a second lightest element. Now because of its lightest nature, we are using helium in meteorological balloon as well as in airship. Now hydrogen can be used, but we know that hydrogen catches fire like an hydrogen. When it combines with oxygen, it leads to an explosion. So explosive reaction takes place. Although hydrogen is lighter, but we cannot use it in meteorological balloon or airship. In airship, we come across one of the Hindenburg as an example, which caught fire. Okay, but here we are using helium because of its lighter nature. Neon. Everyone must have seen a neon light. We have the signboards are there. Even the billboards are there which are there. They glow with a very distinctive and very attractive color. So when this neon gas has been put in discharge lamp, it glows with a very distinctive and attractive color. Okay. Then argon. Argon, because of its inertness, it's been filled in filament lamp. Now see, filament lamp has got tungsten. The tungsten filament is there. Now when tungsten filament gets heated, it emits light. Now when it gets heated, what happens? If you have other gas, then it may react at a higher temperature with that tungsten. But argon, if it's been filled with argon, then the tungsten filament which is that gets heated up, but at higher temperature it will not react with argon because of its inertness. So it prevents the tungsten filament to get oxidized or to get combined with any other things. So that's why argon has been filled over inside that to give the inert atmosphere. Okay. Xenon. Xenon has been used in arc lamps, which we used in film projectors as well as headlights of our vehicles. Now the important use is that like this, what are the arc lamps are there? They give a sense of daylight. What are the light which has been produced? It gives us a sense of daylight. That's why it's been used. Apart from that, it's been used as anesthetic. We may use nitrous oxide, but xenon has got a good use over anesthetic. Okay. Then radon has been used in radiotherapy. Radon is basically a radioactive element. Radon is basically a radioactive element. So we use this in radiotherapy in treatment of some of the diseases. So there we use radon over there being a radioactive in nature. So these are some of the general properties and uses of noble gases. Hope you must have understood this, and thank you for watching.